So next we have the Mayan numeral system. This is a base 20 system. This is pre 1000 AD. Mayans of Central America and Mexico developed a remarkable civilization. Their numeral system with unknown date of origin was uncovered by the early 16th century Spanish expeditions into the Yucatan, now Central America, Mexico. All right. We have a base 20 system. So instead of going 0 to 9, we're going from 1 to 19. Right. So, well, really 0 to 19, but in terms of the numeral values, we're thinking of counting numbers. All right. So that would be the non zero positive numbers. All right. But yeah, we represent a ones place or one value, one single digit as a stone. A stick or a bar would represent groups of five, right? And then the zero would be the shell. So that's why we kind of left it off because the symbol that we would use would be basically a way of representing zero as we know it, but we're calling it a shell at this point. All right. So the numerals from 0 to 19, you get your shell for zero, up to four dots for numbers one, two, three, four, and then everything after that is just some combination of horizontal lines and dots. So five is a horizontal line. A horizontal line and one dot would be six. Two dots would be seven, and so on. All right. So the logic of it is pretty straightforward, I would think. All right. And you can see the appeal of it. Numerically, it just seems to make sense. So 19, for example, would be three of those horizontal lines. Three times five is 15, plus four of those dots, which would get you up to 19 when you put it all together. All right. Any values that were greater than 19 were written vertically. All right. So not the characters themselves, just how they were organized. So instead of placeholders, like I'll just use an example, 7,803. If I were to write that with a base 10, it would be 7 times 1,000 plus 8 times 100. Oops. Plus 0 times 10 plus 3 times 1. But again, we learned that that's the same as saying 7 times 10 to the third, 8 times 10 to the second, plus 0 times 10 to the first, plus 3 times 10 to the zeroth. All right. So our place values were organized from left to right. All right. In some cases, we read them right to left. Here, we're saying bottom to top. That's number one. And also, we're not doing it with base 10 anymore. We're doing it now with base 20. All right. So if I were to write this in a base 10 system, vertically, I might do it as 7 times 10 to the third, 8 times 10 to the second, 0 times 10 to the first, and 3 times 10 to the zeroth. And then if I knew that working from bottom to top is powers 0, 1, 2, and 3, then I would just essentially say, okay, let's get rid of all this stuff. And I would just know that that would be the equivalent of 7,803, which is pretty much, and if you think like, well, who would ever think that way? It's like, well, that's kind of what we do. Like, we just know that this is 7,803 because there are four values and we read it from left to right. So here, if I had something like, I don't know, I'll just throw a quick example here. If I had 1 times 20 to the third, 2 times 20 to the 20 to the second, let's say a 0 here, just to keep the numbers kind of nice, and then let's say a 1 here, right? I might think that's 1,201, just based off of our ordinary base 10 system. But it's really 1 times 8,000, which would be 8,000. 2 times 400, 0 times 20, and 1 times 1. All right, so that would be 8,000 plus 800 plus 0 plus 1. All right, so 1201 in a base 20 system, like if I did that and I got rid of all this stuff, 1201 in the base 20 system would be equivalent to 8,801 in a base 10 system, all right? Because that would be our conversion factor. All right, so it's kind of a departure from what we've been looking at, but it mathematically makes sense. It's just there's a learning curve like anything else. So if I needed to do something like really anything beyond 19, but if I had to do something like 31, I'd be looking at different ways of regrouping in such a way that I'm looking at multiples of 20 rather than multiples of 10, right? So 31 is 120, right? And 11 ones. So what we would do is organize it by place here. So this is the 20 to the, I'll just make a little note here. Yeah, because it's kind of in there, but it's not perfect, I guess. But when I say 120 and 11 ones, it's really the same as saying one of those 20 to the first powers and 11 of those 20 to the 0th powers. So reading from bottom to top, power of 0, power of 1. So the way it would be represented in the Mayan system would be a 1 dot over the symbol for 11, indicating that we have one of those 20 to the first powers and 11 of those 20 to the 0th powers, right? So I'll do a quick side example here. Let's say we have, I'll do 42, all right? So what we would be essentially trying to do is, especially since it's a two-digit number, is we would have two positions, right? I can break it up, but if I look at it as like, all right, what is the maximum number of ones that I can have, and then follow that up with the number of 20s that I can have, that could be a way of thinking about it. But essentially, I want to get multiples of 20 involved. So I would say that I'm looking at 20 plus 22. All right. But 22 itself is, I'll say it this way, it's part 20. All right. So what we have here is 20 plus 20 plus 2. And then if I regroup this, I could look at this as two 20s and two 1s, right? So the way I would represent that would be two dots, right? So going to our table, again, it's organized horizontally, right? Two dots over two dots, all right? So two 20s, two 1s. If I had a 3-digit number, then I could get the 400 involved. That would be 20 to the second power. But it's really just 20 to the 0, 20 to the first gives me the 1 and the 20. The two dots adjacent to one another, give it a little bit of space here, but those two dots adjacent to each other mean 2. So 2 on the 20 level and 2 on the 1 level. All right, put it all together and you get 42. All right, so same idea with the 94. We're looking at 4 in the 20s place and 14 in the 1s place. So that corresponds with this this set of values. 825, without showing the answer, I'll show kind of the breakdown. Well, kind of really no way to show it, but, or sorry, no way not to show it, but I'll try anyway. So 825, again, we're looking at the hierarchy is 20 to the 0th, 20 to the 1st, 20 to the 2nd, 1, 20, 400. All right, that's enough to get me any 3-digit number. All right, so if I have 2 of those 400s, that gets me to 800. If I have 1 of the 20s, that would get me to 820. Right? And if I have 5 of the 1s, then that would get me to 825. So on the 400 level, I need my symbol for 2, which is 2 dots. On my 20 level, 1. And on my 1 level, I need 5. All right, so 5 of the 1s, 1 of the 20s, and 2 of the 400s. All right, and there it is. Kind of looks like a neutral face. All right. Now to go the other way, it really is just a matter of identifying the place value. Right, so this is the 1 level, 20 to the 0th. Oh, that's not a 20 to the 0th, hold on. 20 to the 0th, which is 1. 20 to the 1st, which is 20. And then 20 to the 2nd, which is 400. All right, so this is my symbol for 7. So I have 7 of the 400 on the 400 level. I have 5 on the 20 level. And I have 6 on the 1 level. All right, so that's 2,800. 5 times 20 is 100. 6 times 1 is 6. Add them together, and I'm looking at 2,906. All right. So all of this explanation really just addresses that idea. Same idea with the second example. This one, I mean, this notation I'll dive into a little bit more deeply as we go, but for now we'll just kind of look at it from the different level standpoint. So this is the 20 to the 0th, 20 to the 1st, 20 to the 2nd, 20 to the 3rd, 20 to the 4th. All right, so that's anything to the 0th is 1, 20, 400, 8,000, and then 16 4 zeros after, so that's 160,000. All right, so what we have is 7 at the 160,000 level. I have 10, 13. I'm trying not to look below. At the 8,000 level. Then I have a 0. That's the shell. At the 400 level. 15, 19 at the 20 level. And 11 at the 1 level. All right, so now this is actually the first time, I think, if I'm reflecting back on these videos, that I've even looked at a calculator. All right, the numbers haven't really been that bad. All right, 7 times 160,000 plus 13 times 8,000 plus, I'll skip the 0, 19 times 20, and then plus 11. And so we get 1,224,391, which is what we have here. All right. So now we're ready to tackle the exercises 1, 4, 2.